Lesson 3.8, solving equations by clearing fractions. And this applies both to equations, that is equalities, as well as to inequalities. Okay, so lessons 3.1 through 3.5 were equalities. Lessons 3.6 and 3.7 were inequalities, and as we discussed before, all the properties from up here also apply to 3.6 and 3.7. There is one special property that applies to inequalities about when you have a negative a. And then last 3.8 is both for equalities and inequalities. Okay, so the big idea is if you have an equation that's both an equality or an inequality, either one, and it has fractions in it, you can turn it into a equivalent, i.e. a similar equation that doesn't have fractions. And the reason you want to do that is that these equations are messy. All those fractions in there make it harder to solve. These equations are much nicer. We like these equations. They're much nicer to work with. Okay, so the way you do this is you choose something called a multiplier. And that multiplier allows you to clear out the fractions and get that messy equation to be a not messy equation. So how do we pick a multiplier? How do we choose it? Okay, so here's an equation. T over 3 plus T over 2 minus 350 is 270. Okay, there's some fractions. That makes it a little messy. Well, here's what they talk about multipliers. You can choose a multiplier of 2, 3, or 6. And any of those are going to clear out at least part of the fraction. If you choose 2 and you multiply the entire equation on both sides by 2, what you end up with is that. See here, this 2 multiplied by this guy here, the 2's cancel out, and you just end up with t right there. So that cleared out part of the messiness of the equation, but it didn't clear out all the messiness. You still have a mess there. Similarly, if you choose 3 as your multiplier, and you take 3 and multiply it by both sides, it's going to clear up the messiness on the first fraction and turn it into that pretty little guy. But it's not going to clear up the messiness on the rest of it. As a matter of fact, it probably makes it even messier. So, if you choose 6 for your multiplier, and you take 6 and multiply it by both sides of the equation to maintain equality, it's going to say 6 times t over 3. Well, the 6 and the 3 will cancel, and you'll get 2t. And then 6 times t over 2, the 6 and 2 cancel, and you get 3t. And then 6 times negative 350 gives you a negative 2100. And then on the right-hand side, 6 times 270 gives you 1620. So all your fractions got cleared out. You're only left with integer coefficients, an integer coefficient on each of those t's. And all your fractional coefficients that you originally had have gone away. And that's your goal. Figure out what can I multiply every single fraction by and clear out the fractions and have integers. And you probably notice, what you really want to do is look at your two fractions and pick one number that clears out both denominators. Okay, so that was with an equality. We're going to practice one with equalities and inequalities. Okay, and there's a couple things I want to point out to you is that's just one way of solving a problem which has fractions in it. You could, instead of using a multiplier, you could use a common denominator, and both solutions will work. It's just that it's nice to have more than one way to solve a problem. Sometimes it's easier to use a common multiplier, and sometimes it's easier to use a common denominator. Okay, but either thing is a valid way to solve a problem. So first let's do the common multiplier. we've got a fraction with a denominator of 12, a fraction with a denominator of 15. What number can I multiply by 12? And also, what number is 12 as a factor of, and 15 is a factor of? And so 60, if I multiply 60 by 1 over 12, it's going to cancel out and give me 5t. 60 and the 12 cancel, and I get 5. And then the 60 and the 15 cancel, and I get 4. 60 cancels with 15, and I get 4t. Okay? So that's what happens on my left-hand side. 112t plus 115t becomes 5t plus 4t. But make sure you do the same thing on the right-hand side as well to maintain equality. Okay? And at that point, you just have 5t plus 4t equals 7,740. 9t equals 7,740. Divide both sides by 9, you get 860. And you're done. Okay, like I said, you can, however, use a common denominator for these. So I look at 12 as a denominator, I look at 15 as a denominator, and I say, what is a common denominator of both of those? And 60, again, is a common denominator. 1/12 becomes 5 over 60. 1/15 becomes 4 over 60. Okay? And then I add those two fractions together. 5 over 60 t plus 4 over 60 t becomes 9 over 60 t. All right? And then I have 9 over 60 t is equal to 129. I multiply both sides by 60, okay, to get rid of the fraction. Okay? Or I could have multiplied both sides over 60 over 9. That would have been a possibility too. Okay? And I get down here to 9t is equal to 7,740. Again, divide by 9, I have 860. So either way, of a common multiple of 12 and 5, or a common denominator of 60, either way will work. All right, so let's try with an inequality. And you probably recognize from all the lessons we've done that inequalities and equalities work pretty much the same way, except for when you have a negative a. So, you know, that's the only thing you have to be especially careful of with inequalities. So here we have this messy looking equation, and you're like, hey, let's get rid of those fractions. So what can I multiply by to clear out the 4 in the denominator and to clear out the 6 in the denominator? 12. So I multiply both sides by 12. When I do that, 12 times x over 4 gives me 3x. Okay? 12 times negative 8 gives me negative 96. 12 times 1/6 gives me 2. So I have 3x minus 96 is greater than 2. Then we kill Bill, add 96 to both sides. Then we annihilate Anna. We divide both sides by 3, or multiply both sides by the reciprocal of 3, which is 1/3. And we get x is greater than 98 over 3, which is the same thing as 32 and 2/3. Now, since we did not have a negative a that time, we did not flip the inequality symbol. All right, now here's one that I wanted to show you about. Be careful, especially when you have fractions on either side of the equation, that you don't just focus on the fractions. Because if you do that, in a situation like this, and you just multiply this fraction by 12 and this fraction by 12, thinking that you're going to clear out the fractions, well, you'll clear them out. But the fact that you did not multiply that guy by 12 is going to mess everything else up. Well, let's just see what happens. So you multiply just the fractions by 12. 12 times x over 4 is 3x. 12 times 1/6 is 2. All right, then you kill Bill. You add 8 to both sides. You annihilate Anna. You divide both sides by 3, or multiply by 1/3. And when you do all those steps, which you're hopefully quite used to by now, this is where you end up. x is greater than 10/3. And 10/3 is the same thing as 3 1/3. Okay, now remember, this is the incorrect way. So don't be surprised that I'm now going to show you that, hey, guess what? That's not right. So x is greater than 10/3, which is basically, like I said, 3 1/3. I'm just going to make my life easy and go back and do a check. Instead of putting in 3 1/3, you don't even have to do it exactly. But if you put 3 1/3 back into the original equation, and I get basically 3/4, okay, that's approximately 3/4, minus 8. 3/4 minus 8 is greater than 1/6. That doesn't make any sense. 3/4 minus 8 is something, like a -7 something or another, right? So our check shows that the fact that we did not multiply the 12 by every single element of that equation messed the whole thing up, okay? So when you do that common multiple, make sure you multiply by everything, not just the fractions. Okay, the last one is clearing decimals. Now this lesson's called clearing fractions. Well, guess what? It's also clearing decimals, because decimals are just a fraction with a hidden denominator. 0.7 is actually 7/10, right? So that's its fraction. 0.07 is 7 1/100ths. Okay, so decimals are just fractions with a hidden denominator. Okay, knowing that, we can just clear them out the same way. So you look at the original equation and you say, okay, what is the largest hidden denominator? Well, the hidden denominator here is 100. The hidden denominator here is 10. So the largest hidden denominator is 100. So we're going to multiply both sides by 100. Once you're comfortable with this, you can just think of it as moving the decimal point. But you have to understand why you can move the decimal point. So 100 times this guy, 5.85, is 585. 100 times -9 is -900. And 100 times 2.7 is 270. And now we're at ax minus b equals c. Okay, and so we can kill Bill and get to here. We added 900 to both sides. We can multiply both sides by the reciprocal of 585, or divide both sides by 585, and we get n is equal to 2. Okay? All right, then you can go back and check it by going into your original equation and putting 2 in. So 585 times 2 minus 9 equals 2.7. 585 times 2 is 11.7. Minus 9 equals 2.7. Yep, that's true. So you can solve equations by clearing fractions, because fractions and decimals, okay, and decimals just have a hidden denominator. Okay, so just a summary. To clear fractions or decimals, choose a common multiple, okay, or choose a hidden denominator for the decimals. Multiply each side of the sentence and every element of a sentence by that number. And then after you've done all that clearing, then use your properties to simplify, and then if you do end up in a situation where you have a negative a x and a b over here, okay, then be sure to change the sense of the inequality when you divide both sides by negative a. And that is lesson 3.8.